Okay, now let me share my screen, and before that I need to open the file. Just give me a 30 seconds more. You people should be ready, and let's make it as interactive as possible from our side. Just a second, please. Okay, the file is opening. Let me share my screen now. The screen is playing the Garba, and good to see the Garba has completed very quickly. And we are there on the screen. Okay, so this was the Excel file we were working upon. If I give you the brief overview of it in the 1 minute, there were various portfolios with different allocations to the different assets, right from the bond to the equity to the cash. We had found the return distribution too, that what will be our lowest and highest return if we consider 68 percentage of the times, or I may say that in 68 percentage of the times, what shall be my maximum expected return and what shall be my minimum expected return. And to find this two, you just require the two parameters. One is the average, another one is the standard deviation. Now till now we were working upon the yearly data of the returns. Now I am introducing the value at risk on the monthly data. You have got the monthly return of the portfolio too for all these three kinds of portfolio, yes or no? Now in that, my dear fellas and fellies, our first task would be, see, wherever you try to find any I can call a value at risk, at that time you require the distribution of the returns. Until and unless you do not have the distribution of returns, you will not be able to find the value at risk. Now here in this case, we already have the distribution of returns on monthly basis. Now see, if I try to find the return from the yearly returns, if I try to find the VAR from the yearly returns, then I only have 11 to 12 entries, right, for the yearly return. Now this may not give us the appropriate result that we want. If we take the monthly return and if we try to find the monthly VAR, then I guess we have the enough number of entries to justify our answers. There are 132 entries. Now VAR can be monthly basis, it can be daily basis, it can be yearly basis, it can be any other time period basis. That's perfectly fine. If you want to find the value at risk on the basis of month, that's fine, you are allowed to. Obviously, as per the needs of the practical question, you will be doing, but in practical world, you are allowed to find. Now, if you are finding the value at risk on monthly basis, you will communicate to the client like, see, this is the maximum possibility of loss on monthly basis for you. If you're finding on yearly basis, then how do you communicate? This is the maximum possibility of loss at 5% of probability. That means I'm 95% confident that loss will not be exceed on yearly basis. So that entirely depends on the kind of a purpose you have, right? Okay, so let's find the monthly VAR now. My straight question, everyone should be able to understand those questions well. Now, where we'll be finding the VAR first of all? I'm inserting few rows. Every one of us would be doing it along with me. Let me use the magnifier so that you get in a better way. We are supposed to enter few rows over here before this. So I'm clicking on this 13. Have a right click there, and you must be able to see the option of insert row there. I'm inserting one row, and let me introduce one another row there. So I'm using again the insert, so I have two rows. Okay, let's keep it to 4, 3, and one more. Okay, Now we have the three portfolios. My first question I am writing over here. We want to find value at risk in terms of percentage as well as in terms of the amount of the portfolio at 5%. Now try to understand what is the meaning of it. First of all, let's first do it. I'm giving you 30 seconds so that once you complete it, we would move ahead. Just give me a confirmation that you have inserted four number of rows there. Any one of you, please, or through the chat box, whatever the mean feasible to you. If you are there with me, shall I move ahead better? Okay, one confirmation I have received from Mr. Sagar. The thing is there, that you should be along with me so that I can move ahead. Once you insert the four columns, four rows over there, just give me a little confirmation in the chat box that you are there with me. Okay, from Mr. Dhananjay too, we have received the confirmation. Good to see that. From Miss Neha, good. Miss Chandni too, good. Okay, let's move ahead. Value at risk at 5%. So what I want to really find over here is that at 95% of the confidence level, what shall be my maximum loss? That is the value at risk at 5%. Just reduce whatever the value at risk percentage given to you, and the rest of the percentages is the confidence level of yours. Say if I want to find the value at risk at 1%, so that means I'm 99% confident that my losses will not exceed than the particular amount I find by value at risk at 5%, at 1%. You can take value at risk at any percentage you want. It can be 10 percentage, 11, 12, 13, but among the financial experts and among the statisticians and mathematicians, 1% and 5% criteria is very famous, because 1% and 5% are also used sometimes for the hypothesis testing. So that's why 1% is used in some of the industries where very delicate research is performed, like pharmaceutical industries, where the chances of error should be minimized up to the greatest extent. But 5% can be followed in the social sciences subjects like management, and in some of the other fields related to economics and various other fields too, right? So we generally use the 5%, but whatever the percentage you want to take, no, the remaining percentage is the confidence level of yours. So if I say I want to find the value at risk at 2%, that means 98% of the confirmation I can give that my losses will not be more than that. Okay, how can we find it? First of all, to find that, we need to understand our uh, normal distribution again. You people are already aware about it. Just let me give you a brief idea of it again. So this is how my normal distribution looks like, right? This is the histogram of distributions, and here I have the mean, right? And here I would be having the various SDs. Let me write the SDs over there. On right hand side you would have 1, on left hand side as well you would have 2 again here, 3 here, -1, -2, -3. Now this would be the standard deviations, right? So here 0 is the average mean you have, mean the return you have. So in the first case, the average return I have is, try to understand, the average return of the monthly portfolios. We are supposed to find the monthly VAR right now. Value at risk at 5%, I am writing in the bracket monthly. So monthly mean we require and monthly standard deviation also we require, right? So let's find the monthly mean and monthly standard deviation somewhere. So I'm finding it. I'm finding it below over here. Average in bracket monthly return. right? So equal to AVE, RAGE. Yes, this VAR calculations can be done only if you have these two data. One is the average, another one is the standard deviation of the distributed returns. Else we cannot find it. Average in bracket. Now you would be just selecting the range of the data for which you want the average. So right from the first, and my students will not go one by one, because we people are aware about little bit of knowledge of Excel, right? So what we'll be doing, we would be using the shortcut key here. Control Shift down arrow. So this entire active range of the data up to the last cell would have been automatically selected, closing the bracket and pressing enter. And my dear fellas and fellies, you have the average return on monthly basis, which comes at 0.68 percentage. You would also use the standard deviation formula now, STD. For that, I am writing the SD in simple words for the description. Then I am starting with a sign of equal to STD, and whether we are finding it for the sample or we are finding it for the population. So I told you that we are assuming that it's a sample of the population. We haven't taken the entire data. So let's take it standard deviation for the sample. The only difference between the formula is in denominator you have n and n minus 1. When you are finding the SD for the entire population, in denominator you have n, that would be the total number of observations. But when you are finding it for the sample, in denominator you have n minus 1, because some standard error provision is also made when we are finding it for sample. Okay, so I'm writing S, and all the returns I'm selecting, as simple as that, after opening the bracket. And you people are aware about the shortcut key now, Control Shift down arrow, closing the bracket, pressing enter. So you have got the SD. Now let me convert it into percentage so that we get the better answer, because everything we are calculating right now in terms of percentages, right? So home tab, percentage, and you have got 1.77 percentage as the standard deviation on monthly returns. So let me go to the distribution we had prepared over there. So 0.68 here and 1.77 there. Now I would try to first explain you conceptually, and then we'll move ahead further. Where is my histogram? Where, just a second. Here we were. Okay, so here the mean was 0.68 percentage. Yes or no? Yes, sir. And one standard deviation was equal to what? One standard deviation was equal to 1.77 percentages, right? So 1 SD equal to 1.77 percentages. So how can you calculate this? If I want to find that, see, I told you the probability distributions approximate, right? Here in this region, there were 34 percentage of the probabilities. Here in this region, again, there were 34 percentage of the probabilities. Here in this region, you have 13 percentage, and this region you have again 13 percentage. So in totality, around 94 percentage of the probabilities are lying between the two standard deviations, negative to positive, right? And rest of the area contains 3 percentage. Now say we are supposed to find the 5 percentage VAR. That means the maximum loss at the 5 percentage. So maximum loss comes over there in the negative side, right? So up to this point, if you have 3 percentage, so your 5 percentage would be falling somewhere over here between 1 to 2 standard deviation. Because see, up to 2 standard deviations, you have 3 percentage on left hand side. This is the area till which I have 3 percentage probabilities. But I want to find the 5 percentages, right? And 5 percentages would be lying somewhere between 2 and 1 standard deviations. Now we can use the Z table to find that what is the exact standard deviation where our 5 percentage probability is lying. Z table can be used for this, but Excel has a very simple calculations. एक्सेल के अंदर आपको z टेबल यूज करने की जरूरत नहीं है. You can find the standard deviation score based on the probability you have for the normal distribution by using one function in the Excel. That's it. I hope you have understood till now that I want that, you know, what is the 5% value at risk? The simple meaning of it would be that I want the 95% of the surety that my losses will not be exceeding more than that. But the 5% probability, we are thinking on the negative side. Why we are thinking on the negative side? Because we are right now thinking about the loss. So up to the one standard deviation from 3 to 1, we have the 3% distribution. So it must be somewhere between -1 and -2. Because 5% would be somewhere lying over there, right? If you find the cumulative ones. So this entire total region would be having the 50% of the probabilities. And here as well 50%. So your 100% is completed. Now I want for the 5%, then up to this SD, I have 3. So it must be somewhere between 1 and 2. Now, if we want to do it manually, we are supposed to use the Z table for that. But we'll not be doing it manually, my dear fellas and fellies. Excel gives us the answer automatically. Let's see that how. Which function you can use for that. So now I'm moving to again a fourth row which I had prepared. So here I would use normal, or I may use SD score. I'm just writing as a description. SD score at 5% probability. So we want to find that what is the standard deviation at which the 5% probability is lying. So you will be using the function along with me only if you are ready, because this is the new function you will be coming across with. Just give me a confirmation that you are ready with me, all of you. Till now, if you are there, average is found, SD is found, and you have understood the concept well. Everyone, do I need to explain it further? Please let me know if I am supposed to. That's perfectly fine. If you are seeking the further explanation from my side, that's very, very perfect. Do not worry, better. Has everyone got it till now? And if you are there with me, just give a chota sa confirmation in the chat box. And if I'm supposed to wait for a minute, let me know. Okay, from Miss Chandni, we have got the confirmation done. Good to see. From Miss Neha too, really good. Others, I'm waiting for your replies. If you feel that somewhere I should also give you the further explanation, please let me know. You have got this concept well, right? Shall I move ahead? Okay, let's go further. So we want to find the SD at which 5% probability is lying, right? And if you can recall the formula that we were using to find the value at risk, it was looking like this. See, we were finding first the average return, and from average return we were doing the reduction, and that's where we were multiplying the SD at which 5% probability is there, and multiplied with SD score. So that was the formula we were using. Now see, this can be used in a simple manner like this too. Say if I give you the example manually again over there. So at average, you have 0.68 percentages, right? That is the one thing established. Then one standard deviation stands for 1.77 percentage. Say for example, at 5 percentage, you got the standard deviation score of say 1.65. So that means your 5 percentages probability is 1.65 standard deviation away from the average in the negative side. Try to understand my question very well. If your 5 percentage probability comes at 1.65, that means your 5 percentage probability is 1.65 standard deviations away from the average. So how can we do it? Say 1 SD equal to 1.77 percentages, then 1.65 SD would be equal to how many percentages? Because see, that was the standard normal distribution. Based on that, we want to find the return distribution now. So if 1 SD equal to 1.77 percentage, then 1.65 SD would be equal to how much? So what do? We multiply 1.65 with 1.77 percentages, right? So you get something. Now this would be, say you get somewhere around 2 percentage. I'm just giving you for the example, huh? Say you get 2 percentage. Now that means your 5 percentage probability is 2 percentage away from your average. So 2 percentage away from your average. So you will have to minus it, right? Because we are there on the negative side. So what you will do? You will reduce this 2 percentage from the average. So average minus 2 percentage is the return where 5 percentage probability is there. I hope you have understood it conceptually till now. Say if 1 SD equal to 1.77 percentage, then 1.65 SD equal to what? How did we get the 1.65? I'm just giving you for the example that we can find by using the Excel function, right? That we are going to do right now. But say it is coming at 1.65 percentage. That means between 1 and 2, there is a 5 percentage probability lying. उसका सिंपल इंटरप्रिटेशन क्या होता है कि if 1 SD equal to 1.77 percentage return, then 1.65 SD would be equal to how many percentages of return? So say that comes at 2 percentages. So उसका simple मतलब ये हुआ कि my return is 2 percentage away from the average in the left hand side. So that's why I need to reduce it from the average so that I get the return percentages where 5 percentage probability is lying. Okay. So now you are supposed to find, you must have understood. You are supposed to find, first of all, this 1.65 SD, that how do you get this? Because we have just a SD and standard deviation. SD in terms of return we have got, right? So at what percent standard deviation exactly the 5 percentage probability is there? To find that, you have a function called, everyone would start doing it along with me, equal to normal S inverse. Norm S inverse. So return the inverse of the standard normal cumulative distribution. So this is the function you will be using, NORM S inverse. And you will have to just write the probability at which you want the standard deviation score. And the probability would be 5 percentage, right? So I may write 5 percentage, or in decimals I can write 0.05. Or you just write 5 percentage, then also it's fine. So closing the bracket, pressing the enter. So you must have got it that your standard deviation is 1.644. Your return is 1.644 standard deviations away from your average. This is the SD score you have got in the Excel. As simple as that. So अब तो कुछ बाकी नहीं रह गया, सिंपल सा ये फॉर्मूला यूज करो और हो जाएगा. So average return minus SD plus SD score. So equal to average. ठीक है. Now this standard deviation score is coming in the minus only. So we will not be using again the minus. Otherwise the minus would become plus. So let's just use the plus only there, right? Because it's already there in the minus. No, that's why. Okay. So SD multiplied by SD score. And you have got the return, that is 2.23 percentages. This is the maximum loss you can make on monthly basis with 95 percentage of the confidence. So that is nothing but the 5 percentage value at risk on negative side. Once you are absolutely clear about this, let me know through the chat box. Now, if you want to find it in the rupee terms, we are aware about it, right? Because we already have the portfolio amounts. So what can we do? We can press equal to next to it. The portfolio amount is 60 lakhs. So I'm selecting the cell where 60 lakhs is written, which is C5, multiplied by this VAR percentages. And if you press enter, you get minus 134,081. So if this is the portfolio and this is how the distribution would be based on the distributions I have got over here, then the maximum loss on monthly basis I can make with 5 percentage of VAR, or I may say with 95 percentage of the confidence, is minus 134,081. This is for the first portfolio, VAR at 5 percentage. Or in return terms, I have minus 2.23 percentages. One more way to find this, if you do not want to go through this SD score, no, then you can directly use one more function, and for that you just require average and SD. How you can do it? I'm doing it along with you. Everyone please concentrate with the utmost attention. Equal to नॉर्मल, और नॉर्मल के बाजू में एक इनवर्स करके फंक्शन आता है, ठीक है. सो आई एम यूजिंग द इनवर्स. सो इट आस्क मी कि भाई नॉर्मल के बाद में इनवर्स में तुम्हें प्रोबेबिलिटी कौन सी चाहिए. मैं बोलूंगा कि मुझे प्रोबेबिलिटी चाहिए 5 परसेंटेज. सो आई एम राइटिंग 0.05 comma, then it will ask me what is the mean. I would say my mean is this average. I am selecting B14 comma, then it will ask me what is the standard deviation. I would say 1.77 is my standard deviation. So selecting the cell where 1.77 percentage is written, closing the bracket, pressing enter, you have got the same answer again. For that the function was which one? Normal inverse. Norm dot inverse, that is the function to directly find the value at risk. But I had done the longer way because I wanted to explain it conceptually too, right? So very simple, just find the average return first of all for the distribution, then find the SD and use this function, you get the VAR, as simple as that. And multiply that percentage with the portfolio amount, so you get the amount in rupee now. This is the maximum loss at 5 percentage VAR, or I may say 95 percentage with the confidence. May I have a confirmation through the chat box that you are there with me, everyone, all of you? और कहीं पे भी अटक रहे तो बता बेटा, अभी बता दो. Such a wonderful function you have, no? I mean, you will be able to solve it like anything just in a minute. Now for the second and third portfolio, it's not going to be difficult for us. Let's find it. So here I have the second portfolio where I again require. So what I'm doing is I'm just copying all this for headings and I'm pasting those headings over here, because here as well I require the returns, right? So I'm pasting it there. And I would again paste it. I'm copying this for the third portfolio too. So I'll be pasting over here next to the amount of return here. So Control V again. And let me increase the size of it so that we do not get confused. So I'm increasing the size of this row from here. You may have a double click over there between G and H. So once you have a double click, the column size would have been already existed. Okay. So let's first find the average. So equal to AVE, RAGE, and in average you will have to just select all the monthly returns you have. So selecting the entire range of the data, closing the bracket, pressing enter. For the second portfolio, the average is coming at 0.73 percentage. Let's find the SD now. Equal to STD EV sample, opening the bracket, then selecting all the returns right from the first to the last one, closing the bracket, pressing enter. Now SD is not there in the percentages. Let me convert this into a percentage because you have got in decimals. So I'm using the home tab and from there converting into percentages. Let me increase the decimals. So SD is coming a little bit more in this case on monthly basis. Now two ways to find the value at risk. First you find the standard deviation score and then you do the calculation manually as we do. Another one, you can directly find it from average and SD. And if you directly want to find from average and SD, then you will use the function called norm inverse. And when you have norm inverse, and first you will be writing the probability, which is 0.05, comma, mean. Mean is over here, which is the cell number E14, comma, standard deviation is the cell number E15. Closing the bracket, pressing enter. And you have got the var of this much. Let me convert it into percentages from home tab, inserting the sign of percentage, increase the decimals, and you have got minus 2.945 percentage. So that means with 95 percentage of the confidence level, your return on monthly basis may go to around 2.94. That means the loss may reach to around 3 percentage of your portfolio with 95 percentage of the confidence. So if I want to find it in uh, amount manner, so what I'll do, I'll select the amount over here, that is F5 multiplied with this percentage. Pressing enter, you have got it in amounts, that is 2,35,611. So with 95 percentage of the confidence, I can say to anyone who comes to me for the portfolio management, I would say that, see, your monthly loss may get around 2,35,611, and I'm 95 percentage confident for that. Let's find it for third, and once all these three are found, you will give me a confirmation through the chat box again, every one of you. First finding the average, then selecting all the monthly return of the third portfolio, closing the bracket, pressing enter. Then you find the S standard deviation of sample, right from the first to the last one, selecting the range. And once you have this two, then value at risk is very, very simple. So equal to norm inverse. Norm inverse function will be using probability, I would say 0.05, comma, mean is in cell number H14, comma, SD is in cell number H15. Closing the bracket, pressing enter, you have got the return. Let me convert it into percentages. Now see here in the fourth portfolio, which is the aggressive in nature, here you have more of equity, and that's why your value at risk percentages is also going to 4.17 percentage, which is a very huge on monthly basis, right? So equal to, I'm selecting the amount of portfolio, which is 3 crore 70 lakhs in this case, multiplied with the VAR percentage return. You get the VAR in rupee, which comes at around 15 lakhs 42,281. So I may tell it to the person, the one who comes to me, that see, if you are investing right now 3 crore 70 lakhs, then your monthly loss can reach to maximum of 15 lakhs 42,281, and this I can tell with 95 percentage of the confidence. Is it clear, all of you? जैसे ही तीनों पोर्टफोलियो का हो जाए, आप छोटा सा कंफर्मेशन मुझे दे दीजिए, छोटा सा भेज दीजिए कि सर आ गया है, तो मेरे को मालूम पड़े कि पीपल आर देयर विथ मी. Giving you 1 minute uninterrupted to everyone. Okay, Miss Chandni is doing amazingly well today. Good to see that. Chandni क्या खा के आई हो आज? धड़ाधड़ यस सर दे रही है सब जगह पे. Good, good. Miss Chitra, Miss Dhruvi, good to see that. Chandni would be like, sir कुछ नहीं खाया है सुबह सुबह. Fine, others I'm waiting. Find it for all three portfolios. The value at risk. Mr. Viraj too. Good to see that. Aha, we have Mr. Dhananjay too. Good. Now, very small concept is remaining. Where is Miss Sneha stuck? I'm not receiving the confirmation from her. Sneha, कहाँ पे फंस गए बेटा? कहीं पे अटक रही हो तो बताओ. Okay, done. Good, good. Let's move ahead now. Now, see, you can find the value at risk by this method only if you assume that there is a normal distribution of the data. That means data is there in the bell shape, and even if it is near about the normal distribution, you may use this concept. Now, in overwhelming majority of the situations, you would have the normal distribution of the data only. But there could be some kind of situations where there would be a huge difference between the maximum and minimums, and data might not be looking normally distributed. Now, if we do not take this assumption of the normal distribution of the data, then we may find the VAR by historical basis. So see, that's about finding the percentile, right? Now, when I say that I want 5 percentage VAR, that means my 95 percentage of the returns shall be more than that. So when I say my 95 percentage of the return should be more than that, then I need to find the percentile at 5 percentage. As simple as that. आपने परसेंटेज का कॉन्सेप्ट देखा है ना, परसेंटेज आपको मिलते थे 12वीं में 10वीं में, तो आपको मालूम होगा, थोड़ा सा याद रहेगा. आपका 88 परसेंटेज परसेंटाइल आता है, उसका क्या मतलब हुआ कि आप 88 परसेंटेज लोगों से ऊपर हो. हाँ कि ना? सो दैट मीन्स आपसे ऊपर सिर्फ कितने हैं? 12 परसेंटेज है. अगर आपके 90 परसेंटाइल आते हैं, इसका मतलब क्या हुआ कि 90 लोग आपसे नीचे है और 10 लोग आपसे ऊपर है, अगर आप 100 की बात करते हो तो. सिमिलर वे में 95 है, तो क्या हुआ कि 95 परसेंटेज ऑफ द पीपल हु हैव अपीयर्ड द एग्जाम्स are below you and 5 percentage are above you. So that's what the percentile is. Now here also as well we want to find the percentile only. No, if I say 5 percentage value at risk, that means my 95 percentage of the returns shall be more than 5 and my rest 5 percentage return shall be less than 5 or equal to 5. Is it absolutely clear? Have you got it? So it is nothing but finding the percentile. Yes or no? May I have the answer, please? Through the chat box. Good. So if I say value at risk at 1%, what does it mean? That means my 99% of the returns shall be more than 1%, and 1% of the return shall be, lower than this or equal to this. Is it absolutely clear now? Okay. So we would be finding the percentile if we do not assume that there is a normal distribution of the data, which is much simpler than this. Say if I want to find the percentile, let me introduce one more row over here. So before this monthly return on row number 17, I'm again pressing right click. Here my mouse cursor is over there, you may check it. 17 के ऊपर जाता हूँ, राइट क्लिक और इंसर्ट करता हूँ, ठीक है। और वहां पे अपन पहले वाले में जाके फाइंड करेंगे var on historical basis, var at 5% on historical basis. Now why it is historical basis? Because we want to find it that what is the exact 5% percentile based on the historical returns you have got, because we cannot assume the normal distribution data now. We cannot assume that in the future as well there would be a normal distribution of the data and we would be finding like this. No, we cannot assume that. If we do not assume that, then we'll have to find it on the historical basis. We need to find that what is the exact 5% percentile there in the historical returns. So the function you can use for this would percentile exclusive. Do not use inclusive, please. Exclusive माने के, say if I give you 5%, try to understand. If I use the exclusive, then interpretation of this would be that 95% are above it and 5% are below and equal to this. But if I use the inclusive, that means 95% are either equal to or above this. तो वो है ना, इसके अंदर गिना जाएगा, इंक्लूसिव यूज करोगे ना तो। इसलिए हम एक्सक्लूसिव यूज करते हैं कि हमें 5%, मतलब सभी के सभी 95% है ना, वो इसके ऊपर ही होने चाहिए, इक्वल टू नहीं होने चाहिए कोई, साथ साथ में ग्रेटर देन और इक्वल टू नहीं चाहिए, सिर्फ ग्रेटर देन चाहिए. So that's why exclusive. Is it clear? So percentile exclusive, as simple as that, finding all the percentages. Sorry, array is the range of the data. So right from the first one to the last one, from 14% to the last one, we have the shortcut key Control Shift down arrow, comma. Then it asks the k. k means कि कौन से परसेंटेज पे चाहिए भैया परसेंटाइल तुम्हें. मैं बताऊंगा कि मुझे चाहिए वो 5% पे. परसेंटाइल का जो रैंक ये चाहिए ना, परसेंटाइल का परसेंटेज चाहिए वो 5% पे चाहिए. सो आई एम राइटिंग 5% देयर, क्लोजिंग द ब्रैकेट, प्रेसिंग एंटर. You have got something around 0.245. Let me convert it into percentage now. Increase the decimals. So this is the return. इसका मतलब ये हुआ 2.46% का कि 95% of the returns are more than this and 5% of the returns are more than or equal to this. This is the 5% value at risk only. Percentile, as simple as that. This is on the historical basis. See, here we got 2.23 based on the standard normal distribution. But if we do not assume the standard distribution, normal distribution, then we may take this 2.46 percentages. Let's do it for second, everyone. I am copying over there. This one, the heading, var at 5% here, and again over there in the third one. So equal to percentile exclusive I am using, not inclusive. You people have got it now. Why I am using the exclusive? Because we want the greater than, not greater than or equal to, right? So I'm selecting all this column or all this numbers, comma. Then it will ask me, you want the percentile at what percentage? I would say at 5 percentile I want it. the returns, closing the bracket, you have got value at risk. As simple as that. Let me find the percentages now. 3.23 percentage. And if you multiply this percentage with the amount of portfolio, you get it in absolute amount. Is it absolutely clear now? थर्ड वाला करके मुझे छोटा सा फाइनल कंफर्मेशन अभी दे दो. So that would be the end of the portfolio return calculation. We have, in this worksheet, we have found the monthly return, we have found the portfolio returns, we have found value at risk. This all concepts we have done by using this only. So practical exposure of the Excel has been given to you for the second module. One more concept of arbitrage pricing theory is remaining, which will be done in the next lecture. And then we can move ahead to the last module of portfolio management, which will be taking just 2 to 3 sessions, not more than that. Do not worry, because majority of the things of portfolio management too we have covered here. बहुत सारी चीजें हमने यहाँ पे सेकंड मॉड्यूल में ही कवर कर ली है, लाइक फाइंडिंग द पोर्टफोलियो रिटर्न्स, फाइंडिंग द स्टैंडर्ड डेविएशंस ऑफ इट, फाइंडिंग द एवरेज ऑफ इट. तो वो पोर्टफोलियो में आता ही है, तो हमने यहाँ पे ही कर लिया, तो फिर वहां पे वो रिपीट नहीं करेंगे, तो 2 लेक्चर ही वहां पे चाहिए, ज्यादा नहीं चाहिए. चलो, how many confirmations I have received? Let's see that. Here I have received it from Miss Neha. Is absolutely clear till now? Not yet. Okay. अब तक जो भी मेरे साथ हो, आपने हिस्टोरिकल बेसिस पे एंड नॉर्मल डिस्ट्रीब्यूशन बेसिस पे दोनों पे वैल्यू एट रिस्क फाइंड किया है. छोटा सा कंफर्मेशन दे दो चैट बॉक्स में प्लीज. कहीं पे भी अटक रहे हो तो बता दीजिए. कहीं पे भी ऐसा हो कि नहीं सर समझ में नहीं आ रहा है तो बता दीजिए. गुड. Okay, so that's it from my side for this lecture. Let me stop the recording now.